Hey everyone, welcome to the next part on antiderivative rules, indefinite and definite integrals. We're going to focus on success criteria C, where we want to be able to find particular antiderivative functions for given conditions. So what that basically means for particular, it means let's say we had an indefinite integral, like so, and then we found that the antiderivative is like this. The particular one means we're going to actually solve for that C value to give us a very specific a single answer for the antiderivative function. So that's what we call the particular antiderivative function. All right, so just to recall, we had a slide like this previously, and we said if we had an antiderivative of 2x dx, we found that that is going to be x squared as the antiderivative function, but make sure we add a plus c because it could be any one of these, red, blue, green, and an infinite number of other options. However, sometimes they're going to give us some additional information, so what we call given conditions, extra info to help us solve for that C value. So let's say the antiderivative function is some capital F of x is what we're looking for a specific one. And we know it's x squared plus c, right? Now let's say we're solving for this specific one right here, this red curve, okay? So we're solving for this specific or particular red curve, and they give us the information that at 1, the y value is 4. Or what they might say is, for the extra information, they might say f, capital F of 1 is equal 4 as a given condition. So with that, what we can say is, well, if the x value is 1 and the y value is 4, then we'll be able to solve for the c and get 4 is equal to 3, or sorry, 1 plus c, and find that c is equal to 3. So we can say that the antiderivative function for this particular one will be x squared plus 3. And that makes sense because here is the shift up in 3 right there, which matches with that 3. So it makes total sense. So let's practice in the next part. Okay, so here's 2 practice examples. Why don't you pause and try to see if you're able to solve these. Okay, so for the first one, we're given a derivative function f prime of x, and they give us the original f of x function, or sorry, a given condition for f of x. So we want to find the original f of x function. Okay, so to do that, what we would do is we would take the indefinite integral of the derivative function and solve for that. So when we do that, we get 8 times x to the 4th, and then the reciprocal of the power, plus 3x plus c. And this would be the original f of x function. Okay, and I'll simplify it a little bit. So it'll be 2x to the 4th plus 3x plus c, and that's the original f of x. Okay, so we're trying to solve a particular antiderivative, so we got to solve for that c by using this given condition, f of negative 2 equals 4. So that I know that the y value is 4 for f of x, and the x value is negative 2. And I'm going to solve for c. So 4 is equal to negative 2 to the 4th power is 16, and then it'll be minus 6 plus c. So it'll be 4 is equal to 32 minus 6 plus c. So 4 is equal to 32 minus 6 is 26 plus c. And then if I subtract 26, I'll get c is equal to negative 22. Okay, so the final answer would be f of x is equal to 2x to the 4th plus 3x plus this new c of negative 22. So I'll just erase the plus and then say that this is actually minus 22. So this is the particular f of x, particular one. All right, for this next problem, this is one that you might have seen if you're taking a physics course. So you got a ball that's thrown straight upward by a student with an initial velocity of 10 meters per second. So I'm going to actually write this down, initial velocity of 10 meters per second. What that means is when time is 0, the velocity is 10. So v of 0 is equal to 10. The ball leaves the student's hand at a height of 1.5 meters from the ground. So height of 1.5 meters from the ground. So that means the original height s of 0 at time t equals 0 is equal to 1.5. And then if the Earth's gravity, and then they give us the acceleration function, is the only force acting on the ball, find the position function S of t. Okay, so what we're going to do is we're going to start with a of t is equal to negative 9.8 as our starting point. And then we're going to work our way backwards to our goal of S of t. Okay, so our goal, basically this is what we're going to do. We're going to start with the acceleration function. We're going to integrate to get the velocity, integrate again to get the position. Integrate. So this is our game plan. Okay, so we're starting with acceleration at negative 9.8. So I know if I do the definite integral of the a of t dt, I'm going to end up getting the velocity function. Okay, so let's do that. So I get, or the indefinite integral of negative 9.8 dt, and that's just a constant, so that's going to equal, so this is the velocity. This is going to equal negative 9.8 t plus a constant c. All right, so before we integrate again, we need to solve for that c. So we'll use this condition right here, this original velocity condition, to solve for that. So I'll use v of 0 is equal to 10, and then solve for that. So I know 10 is equal to that, the velocity, and then negative 9.8 times 0 plus c. That goes away, so I know c is equal to 10. So that means the velocity function is now negative 9.8 t plus 10. Awesome. So now to get the position function, I'll do the integral one more time. So we got the velocity function. Now let's get the position function. So doing that one more time, I know that the position function will equal the integral of the velocity function. So the integral of the velocity function is negative 9.8 t plus 10 dt. When I take the integral of that, I'll get negative 9.8 times, this will be t squared, and then a 1/2 plus 10t plus a new c. Okay, I'll simplify that and get negative 4.9, negative 4.9 t squared plus 10t plus c. So that's the position function, but we want to get our particular solution. So again, here is another condition that s of 0 is equal to 1.5. So 1.5 is the position when I have negative 4.9 times 0 squared plus 10 times 0 plus c. These go away, and then I'll find that c is equal to 1.5. And so overall, to finish up the problem, I will get a position function of negative 4.9 t squared plus 10t plus 1.5 as my position function. So this will probably look familiar to those of you that took physics, because the general kinematics equation you should see is like that h of t is equal to like 1/2 the gravity, or negative 1/2 gravity times t squared plus the initial velocity t plus the initial height. So that looks like it makes sense where the initial height is 1.5, the initial velocity is 10, and then that gravity, or half the gravity, is 4.9. So just some connections there. So now we know how to find these particular antiderivative functions. If the original function is f of x, and then they give us some information about the antiderivative, like f of a is equal to b, then we can use that to solve for c, and then find the particular antiderivative functions.